Alright, so I believe I'm recording. So please let me know if these videos are helping you, or if you can think of a way that I can improve the videos to help you a little bit better. Identify the parent function. Well, here we see absolute value. The parent function that we're starting with here is the absolute value of x. Now, the order of the transformations, I'm going to do horizontal shifts left and right first. So this new graph that I get from using this parent function is to shift this parent function to the left 4 units. So even though that it says plus 4, I'm affecting it inside the parentheses, and what this new function is going to be is the absolute value of x plus 4. Now, my next transformation is going to be this, use the resulting graph. I never go back up and start with the original. It all builds on itself. It all builds on top of each other. So now I'm going to move outward and look at the output of this absolute value function, and I'm going to deal with this 2, and that 2 is multiplication. That 2 is a vertical stretch, by a factor of 2. So I'm going to take the resulting graph of G1 and vertically stretch it by a factor of 2. So that would be like this. Now I'm going to take that resulting graph and reflect it across the x-axis. And then finally, to obtain the final graph that I want, I'm going to take the previous graph and shift it up 1 unit. So let's come in and give descriptions. I said them verbally, but let's type out the descriptions. Make sure we're answering the questions. So here, the parent function is the absolute value function. So to obtain my first graph, and I just didn't know what else to call it but other than G1 for the 1 for first graph, to obtain that graph, we shift the graph of f, our parent function, to the left, shift the graph of f to the left 4 units. So that's the inside the parentheses when you're affecting the domain. That's the bizarre description, or at least bizarre if you ask me. Now here, to obtain my next graph, that I'm just calling G2, I'm multiplying by 2 on the output of that function. So it's a vertical stretch. Or vertically stretch. The previous graph, which was what, G1? By a factor of 2. It's going to stretch and get 2 times away from the x-axis. There was nothing bizarre about it. When you're affecting the range coordinates, it acts like you would think that it would. Now, this negative sign that's in front of that 2 is going to be a reflection across the x-axis. So to obtain the the graph of what I'm calling our G3, we reflect the previous graph that I numbered G2 across the x-axis. And now finally, to obtain the graph of G, which is my final answer, because this is my last transformation, is to shift the previous graph, shift the graph of what I called the G3 up 1 unit, or 1 unit up. Alright, so let's go to that Desmos graphing calculator and check and see if this is the correct answer, if this description is correct. So if we go here, we know that the graph that they're asking us to get my final answer is, do I have absolute value symbols? What if I just typed, yeah, I just hit shift and looked on the keyboard for a vertical line, and it recognized that I wanted absolute value. So if I knew nothing about this transformations, and you just asked me to graph this -2 times the absolute value of the quantity x plus 4 plus 1, well, that would be my answer. That would be my graph. Let's see if I can't, through a series of transformations, start with the absolute value and build up to that. So my first graph is going to take this parent function and shift it to the left 4 units. The plus 4 is misleading, that it's 4 units to the left. So there you have it. I started with the absolute value that had its vertex at the origin, and now its vertex is to the left 4 units. So then my next graph is going to build off my previous graph, and it's going to be a vertical stretch by a factor of 2. So it's opening more narrow. And now the negative sign, I'm going to reflect that. And actually, I could change the order of this 2 and the -2, or I could have done it in the same step, but I just want to break it down and not do too many steps at once for you. If I reflect the previous graph across the x-axis, that's what that negative sign on the outside here is doing. And you can see that the absolute value opened upward, but now with the negative sign, it's opening downward. And then finally, my final answer is going to take the previous graph and shift it up 1 unit. So it's going to take this graph that I call G3, and it's going to shift it up 1 unit. So the question is, this graph that I arrived at, I started with this absolute value, I shifted it to the left 4 units, I vertically stretched it, I reflected it, and then I lifted it up 1 unit. So all those little transformations is at the same graph as had I just graphed it without any knowledge of these transformations. And look, it is, because here's the graph if you graph it just without knowing any knowledge at all about transformations, shifts left, right, up, down, reflections, stretches, and we can see that we have built this graph from this parent function. We started with this absolute value of x, and through just one transformation at a time, we built the function that they wanted. So I hope this helps. I'll talk to you later.